And a very, very warm word of welcome to our telematics revision broadcast. Thank you very much for joining up with us. What we intend to do today is to have a look at the second term's work, see if we can bring it to you in a very, very simple way that it will be easier for you to revise. Now, what I must mention to you is that remember that throughout the course of the term, we have sent you lessons. And please, when you listen to this or you view this revision, please have a look at your lessons as well. Have a look at the revision lessons also that we have sent out to you. I think that if you do that this everything will make much more sense to you. Okay, so without further ado, let us have a look at what we intend on doing today. Now, as I've said, we are the purpose of this revision for today will be the following. Firstly, remember that this is a revision; it's not teaching. We have taught all these lessons to you. We've sent out all the notes to you. We've sent out all the lessons to you. So all that we are doing is we're going to revise the lesson. We're going to look at some of the perhaps difficult parts and some of perhaps the much easier ones as well. We're going to do geomorphology today. You can score good marks with your geomorphology. Okay, then we are going to have a look at the term 2 topics, as I've said, the geomorphology section. Then we are also going to have a look at how to study the topics. And that's very, very important, how to study the topics. And it's very important that you pay attention when we show you. Perhaps it could be an easier method that could just make you and save a lot of time for you when you start to study that topic. Then we are going to unpack and discuss questions. Now, in our previous revision, I've promised you that every revision we will discuss a different type of question and unpack a different type of questions throughout the year. Okay, and then, and this is very important, grade 11s, that we are going to integrate most, or perhaps all if possible, the things that we're going to revise with you with Mapwork. Remember, especially when it comes to geography, you cannot prepare yourself for a geomorphology examination without keeping your Mapwork in mind. That's very important. You must always study your geomorphology section, especially with Mapwork in mind. And that is why we are going to attempt to integrate it as far as possible with Mapwork. Then the lessons that we have sent to you will be available on your phone. You can go to the poster of the WCED. We've got geography links out to you. And please, if you're still not sure about anything, please go to that, and I ensure you will be able to study the work and understand the work much easier. Okay, grade 11s, with every revision work that I do, I usually do this with you. The questions that geographers ask. Now, there's a reason why we do it for you. If you know the questions that geographers ask, you can anticipate questions for the examination. Remember, you're not spotting the questions. There's a big difference between spotting and knowing the questions that geographers ask. Remember, your teacher is a geographer. And when you look at your all the textbooks on the market, they have been written by geographers, and geographers think in a special way. And so if you understand the questions that geographers ask, you will see how easy it is to apply the content of your geography, whether it's on the map, whether it's on the cartoon, whatever they base the question on, you will be able to do it. Okay, let's have a look at the questions that the geographers ask. The first one, what is it? And I want you to always bear these questions in mind. The second one, where is it? The third one, why is it there? What does it look like? How did it happen? What is the impact? And how can it be managed? Now, when you study or prepare yourselves, whether it's for a class test or for exam or a task, grade 11s, please remember that it doesn't matter what topic you are busy studying. Ask yourself these questions and try to study towards these questions. I would like you to repeat that sentence that I've just said. Always try to study towards these questions. If you do something like horizontal layers, ask yourself that question. What is it? It's horizontal layers. Where do I find it? Why is it there? What does it look like? Right? What happened? How did the landforms, how were they formed? What is the impact of all these landforms on the environment? And how can it be managed? I just give you a simple example of only one topic. And I can assure you, please apply these things on the other topics as well. Okay. Now, the most important question that we have in geography is called your data response questions. You should know that by now. If you ever look at your examination, definitely this is the majority type of questions. Now, what is a data response questions? If you just break it up, it's data. You are supplied with data and you are required to respond. What is your response to the questions by having a look at or rather with regards to your different type of data. Now let's have a look at the different types of data that can be used in a geography question or a question paper. Firstly, of course, maps. Of course, geography means maps. Secondly, diagrams. Thirdly, case studies, statistics and graphs, infographics, and cartoons. Now, during the course of this afternoon, we are going to have a look at one or two of these as an example. And as I've said, as I've promised you, that every one of this revision activities that we're going to have with you, we will definitely have a look at what must you do when you are confronted with each of these different types of data. Okay, now what's very important is this. You must be in a position to apply the different types of data on your content. And I'm sure as we proceed through this afternoon, you will definitely get a lot of tips and see how I apply these things, especially on your topographic maps and photos, because those are the two most important things when it comes to geomorphology. Right. Now, when we start off, with grade 11, for the geomorphologists, there's one thing that we must do. We must go have a look at what have you done last year, right? And there's only one thing that you must remember. This has to do with sedimentary and igneous rocks. Now, let's have a look at it. Your sedimentary rock. Here we've got a photo of it. What's very important, sediments deposited by winds, water, and ice built up in layers. Here you can see the different layers there. Right. Have a look at the igneous rocks. You will see what is this? Is magma that rises through the crust. It cools down and crystallizes into new rocks. Now, you know that about close to 70% of the content of the grade 11 CAP syllabus has to do with this. You've got to know this as a background with regard to what you have done in grade 10. Okay, so let us have a look. Now, if we have a look at our grade 11 CAP syllabus, then these are the things that we are going to have a look at. When it comes to sedimentary rock, we are going to have a look at horizontal layers. We're going to have a look at mesas, buttes, and conical hills. And inclined strata, we're going to have a look at Geester, homoclinal ridges and Hogsback ridges. Your igneous rocks, which will be your massive igneous rocks, batholiths, lopoliths, laccolith, and your sill, your dike. And of course, the characteristics and processes of granite domes and tors. So these are basically the things on which this afternoon's discussion will be based. Right. So we are going to kick off now with the first topic in grade 11 geomorphology that deals with topography associated with horizontal layered rocks. Now, if you ever look at horizontal layered rocks, as I've shown you in the previous slide, this means the rocks horizontal. This is how they have been layered and deposited upon for these rocks to form. And we are going to have a look at what does the topography look like if you have these types of rocks. Okay, now it's very important that you must know that these are the types of landscapes that you will find them. You'll find your hilly landscapes. Okay, as you can see here in the photo, it consists of rounded hills and gentle slopes. Your basaltic plateaus formed by highly fluid basaltic lava, and they are deposited layer upon layer upon layer, and until you get your basaltic plateau. And then your canyon landscapes. There you can see canyon landscapes develop where you also have your horizontal layers, but they erode at different rates that you've got there, because you've got hard and soft layers that in your canyon landscapes. And then the Karoo landscapes that you find here in South Africa consists of landforms like mesas, buttes, and conical hills. Now, of course, there's no ways that we can have a look at all of this in the short time that we've got. We are going to concentrate here mostly on the canyon landscapes and on the Karoo landscapes. Now, what's very important, grade 11s, is that you must know how canyons are formed. And that is very, very important that you must know that. Now, let's have a look at our diagram here. The first thing that you should notice when it comes to canyon is that, can you see we've got our horizontal layers here? Remember, we are busy with horizontal layers. Here we've got a soft layer, and then a hard layer, and then another soft layer, and hard layer, and so forth. And it's important that you must know that this was the initial level of the land. So what happened? We have a river here, and that river has found a weak spot or crack in which it could erode much faster. Now, let's see what happens over time. Now, what happened over time is the following, is that the rivers erode vertically and form deep valleys, nearly like a stepped slope that you've got here, right? Now, that's very important that you must know that. Now, of course, it didn't happen overnight. We look at millions and millions of years that it took for a river to actually erode and through this landscape, and we form this hard soft layers with regard to canyons. Now, here I've got a photo of the Grand Canyons, and if you have a look at this photo, you will see the following. Here we've got the river here, right at the bottom. It's exactly the same that river that we had in the diagram. Remember that this river, it first flowed on that height. That was the height where I'm pulling the line, drawing the line now. That was the height of this whole area now. And then the initial height, and then the river came and it eroded vertically into it. And see what this beautiful canyon that has been formed because of the river there. So that's very important that you must be able to actually explain how canyons have been formed. Remember, what is my key? My keywords are hard and soft layers. Firstly, horizontal layers, and then we've got one hard layer, one soft layer, one hard layer, one soft layer. And what happened then? A river on top started cutting through this whole thing, eroding through it, and then eventually we've got the canyon as it is there on the photograph. So that was the first one that we had to look at canyons, how canyons are formed. Then this one, the next following one, is the Karoo landscapes. Now, those of you who have been through the Karoo in South Africa, definitely you've came across this and you've seen this beautiful landscape. I love this landscape. A dry but beautiful. Let's have a look at this. Here we've got the following. And if you can remember in our introduction, we said that the most important things that we are going to have a look at would be the butte the mesa, and the conical hill. Now, again, grade 11s, remember that everything starts off with the same thing. Eventually, that whole layer was the same height. And then rivers came and it cut it up into different blocks. Have a look at this. So here we've got, this was the original height of this whole area here. See that there? This whole part has been eroded, and you can still see the rivers that has eroded it away. Now, what has happened is that the first one that I want to talk about is your mesa. Now, as I've mentioned, this was the initial height, the plateau that we have here, right? And what happened? This part, the river eroded this, and eventually you've got your loose standing mesa then. Now, loose standing, your mesa is a large, flat-topped mountain. And it was formed by this plateau that became narrower and narrower and narrower. And the most important thing is, just have a look at this. It has a hard, resistant layer on top. That's very important, that you must know that about the mesa. And then the butte. If you have a look at the butte, you'll see, but what's going on here? This butte is just a smaller mesa, and that's exactly what it is. This mesa could have been cut up, eroded again, and become smaller, and also by means of scarp retreat. So what has happened actually here is, here we've got our butte, here we've got our mesa. It's just a smaller version of your mesa. Also, it has a hard, resistant top. You must know that when with regard to the mesa and the butte. And the last one would be the conical hill. And the conical hill, you know what happened here? That hard, resistant layer on top has been removed. It has been totally eroded away. And then you will only get this, a pointed landform that is called a conical hill. So this is very, very important that you must know. You must be able to identify all of these landforms, and most importantly, you must be able to describe what it looks like and then how each of these landforms were formed. I'm coming back to that again later on. Okay, now, what's very important, as I've said in my introduction, has to do with map integration. Now, if we have a look at the previous slide, right, this is more a top view. Now we're going to have a look at what does it look like on a topographic map. A photo, what does it look like? Let's have a look. So here we've got this. Now if we have a look at the photo, this is what it looks like. We've got our mesa, and there we've got large flat top, and we've got a hard layer on top. So that will be our mesa, all right? But what's very important, and grade 11s, I can promise you this. If you get a topo map in the exams, and there's a mesa on the topographic map, your teacher is going to examine it. So that is why you must integrate this work with your Mapwork section. That's question 3 in the new exams. Have a look at this. Here we've got our mesa. Now this mesa here is exactly the same one here. This is the photo, and this is exactly the same topographic map of that. Let's have a look at that. The first thing that you have a look is, look at the large open top. Here's this a white area here. In other words, no contours there, right? So that is your flat top, which represents your hard layer. Then have a look at your contours. You'll notice that when you have a look at the contours, you first get the contours close to each other, and then they will become a bit further apart. In other words, they're going to have a steep slope. There we've got the steep slope. Look at that, the hard layer is a steep slope. And then it becomes more gradual, and that is why the contour lines are further apart. Grade 11, this is very, very important, that you must be able to see the relationship between this photo and the topographic map. That's very, very, very important that you must be able to see them. Remember that when you get the topographic map, it will be a top view, right? And this one will be a side view where you are looking towards the mesa. Right, so that is what the mesa looks like. But we've also learned that you also can have a butte and a conical hill. Now, what do they look like on a topographic map? These two are perhaps the two most well-known buttes in South Africa. They call Teebus and Koffiebus. Now, just have a look at this. Look at the difference between the contours here and the contour lines there. The first thing that you notice is the white section on top. If I look at the previous one, look at the large white section there. If you look at the following one, you'll see it's a bit smaller. And here at Teebus, it's even smaller. So what's happening here is that we here, the hard layer, the butte has become a little bit, the mesa has become a little bit smaller, and now we have that the butte has been formed here. This one is Koffiebus. But look at Teebus. And then you will see that it's even smaller there. So what's happening here is that because of a process called scarp retreat, you will find that the butte is being made smaller all the time. And eventually, what's going to happen is that, you see, there's a hard layer. You can see it's nice and flat there. Look at that one, also hard layer. But in a few million years, this thing will be removed, completely eroded. And then you will get a more pointed landform. And that one will be your conical hill when this has been, the hard layer has been removed. So grade 11s, please remember that what you must know is you must be in a position to identify your mesa, the butte, and the conical hill on a topographic map. And you must be able to give reasons why you have identified them. Okay, let's have a look at this one. Here we've got a topographic map where all three of them appear. Let's have a look at this one. Immediately look at the large white opening there, right? The smaller white opening here, and you can't even see a white opening on the conical hill. In other words, this one would be the mesa, this one would be the butte, and that one would be the conical hill. Now, what's very important is, remember in the previous slides, I showed you photos of it. But you must also be able to draw a cross-section through each of these landforms. Let's have a look at this. Here we have the conical hill. Let's start off with the mesa. The large top, have a look at that. The large white area there. There's the mesa. Right? The butte, a little bit smaller. That would be conical hill. The hard section has been removed, so you've got only this that's been left. So grade 11s, please make sure that you are in a position that you can identify with reasons these different landforms on a topographic map. Okay, but remember, that's not all that you should be able to do in Mapwork. Let's have a look at this. Here we've still got the same map. And what's very important is that you must always integrate your map skills when you're busy with your theory. Things like distance, things like, say, direction, right? You must be able to integrate that with your content. Now, have a look at this. What we've got here is determine the bearing from the trig station on the conical hill to the mesa. Now, let's have a look at this. Remember, bearing is very important. You must be able to do that. Let's have a look. What must be done? Here we've got our north line. That would be the bearing, and all you need to do, you protect them, and you measure it, and you'll get 154 degrees. So, remember grade 11, when you are busy with maps, it's not only it's not only the things, the features that you must be able to identify on the maps, but your map skills must be practiced always over and over again. There's one thing about map skills and calculations, right? Map skills and calculations you can only do, practice makes perfect. You can only do that by means of regular practice and practice and practice all the time. Okay, so we hope we've shown you now how this can be integrated into your question paper, how Mapwork and your content can be, they work like this all the time, integrated all the time. Remember, there's nothing like here's my content, here's my Mapwork. These two work together like that all the time. Okay, let's have a look at this, how the utilization of these landscapes by people, how can they be used? Now, the Karoo landscapes, I've got a beautiful photo of Karoo landscapes here in South Africa. It can be used for grazing and suitable for sheep farming. Okay, that would be the Karoo landscape. Now let's have a look at the others. The canyon landscapes for tourism, especially your canyons, whitewater rafting and hiking, right? But the problem is that transport routes very, very difficult to construct with regard to canyon landscapes. Your hilly landscapes that I've also showed you photos in right at the beginning, that is suitable for settlement and farming. And your basaltic plateaus, tourism, especially because of the striking scenery that you get there. So you must also be able to say how can this be utilized, your different landforms and your different landscapes that we've got here with regard to horizontal structures. Now, the following one, the second topic that we have, would be topography associated with inclined rock strata. Now, if we have a look at inclined layers, there's one very important thing that you must understand when it comes to inclined layers. When we did our horizontal layers, these were the layers, right? Horizontal. But when it comes to inclined, that's what happened, okay? The one layer part of thing, perhaps by means of volcanism, it has been tilted like that, okay? So now we've got an inclined or tilted layer. What does this look like, right? And, what can we do about these things? The inclined layers. Now, the first thing that I would like you to do is I want to start off here, of course, with the map skills. Here we've got the topographic map of Brits, and here we've got the line AB. And the question is, which one of the diagrams represents a cross-section from A to B? Which one of these diagrams? And if you have a look at these diagrams, okay, here's A, there's B, immediately, you must notice the following. Here we've got contours close to each other. And on this side, they are much further apart. Now, this is very, very important. If you don't understand this, you won't understand inclined layers. So, if you have a look at this again, you expect that on the one side here, we're going to have a steep slope because the contours are closer to each other. And on that side towards B, the slope is going to be more gradual because have a look at the contours much further apart. In other words, the only diagram that represents the cross-section from A to B would be diagram number 3. Now, what does this all mean? This means the following. That here is a photo of what inclined layers look like. So, have a look at this. Here you see a very important thing you must notice here. And this is the following. That on the one side, you'll have a gentle slope. And on the other side, you'll have a steep slope. Can you remember our diagram that we had? A steep slope on the one side, a gentle slope on the other side. Now, why? We have on the steep slope, we've got a softer layer. And you know that weathering and erosion can take a much faster pace. It can happen when you've got a softer layer. But when you've got a hard resistant layer, it's going to take much longer. And therefore you've got the gradual slope on the side. Look at the lovely steep escarp that is also called on the side. And this side, where you've got your gentle slope, that is called your dip slope. Your dip slope. Okay, now that is a photo. Now let's go back to the map that we've just shown you. Here we go. Can you remember we had the dip slope, the contours far apart there? And on this side, the contours closed, and that is why we've got your gradual slope here. And on this side, we've got the steep slope. So what's very important that you must remember when you are busy with inclined layers? The first thing that you must have a look at is where do I find my steep slope and where do I find the gentle slope? That is easy. You can see it if they give you a diagram, it's easy. Give you a photo, it's easy. If it's on a map, topographic map, then the only clue that you've got would be your contours. Please remember that. As soon as people talk about slopes, you must know that contours is the thing that I've got to look at, right? Because contours indicates the type of slope that I've got, right? So now you're busy with you've got your topographic map, and it's in question 3 that this has been examined, and they ask you now, where's the dip slope and where's the escarp? It's quite easy if you understand contours and if you know your work. Because if you understand contours, then you know that here, where we've got this closer to each other, I will get my escarp. And here, where they are further apart, I will have the dip slope. You must also remember where a very popular question is, where do we find the hard resistant layer and where do we get the softer layer? A very important question, and that's also easy. Because if you have a look at this again, here you'll get a steep slope. Why? Because the softer layer, erosion and weathering, it could happen much faster. But here, if this rock is so hard, you can see it's exposed here. This is so hard here. And erosion cannot, I mean, it takes much longer, millions more years than in the softer layer. And that is why you have, on the one side, you've got the escarp or the steep slope, and on the other side, you've got the more gradual slope. Okay, so that is very important, right? The inclined layers, what must I remember? Steep slope on the one side, gradual slope on the other. That's your key. That is where everything starts when it comes to inclined layers. Okay. The next topic, the following topics that I would like to discuss has to do with topography associated with massive igneous rocks. Topography associated with massive igneous rocks. Now, what's important here is you must again think that first slide that I showed you, the difference between your sedimentary rocks and your igneous rocks. Remember these first two that we've done, the horizontal and the inclined layers, right? Those would be your sedimentary rocks. Now we are moving to a total new type of rock called your igneous rocks. Granite is an example. What must I remember? It has been formed deep below the Earth's surface, where it cooled off, crystallized, and then this was formed. That is what I must remember. Can you see, grade 11, what I'm trying to tell you? If you work with sedimentary rocks, like we've done now in the previous two topics, please, you must visualize this rock all the time, right? You must have a mental image of the rock. Then it's so much easier to understand. The first two, we had layered rocks. Why? Sedimentary rocks. Right? Now, no layers. Absolutely no layers. Because now we've got, with cooling that took place far below the Earth's surface, where these rocks have been formed. Right. So, let's have a look at the topography associated with massive igneous rocks. Now, here we go. Let's have a look firstly as at the massive igneous rocks, more intrusive features of them. The first one would be the batholite. Now, the batholite is the largest of all intrusive forms and is usually made of granite. So what happens is you've got a lot of magma deep below the Earth's surface, it cools off, and there we've got our batholite. That's the first feature. The second one is a lopolite. Now, have a look at this. Here the magma, just follow me here, the magma intrudes between the layers. You see we've got sedimentary layers because we've got layers there, right? Now what happens now is that this thing is very heavy, and now these layers cannot support the weight thereof. And what happens now, it sinks down. And now you've got this nearly saucer-shaped intrusion, right? So you can see it looks like a saucer that has been formed because of the weight. It couldn't support the weight, and it sunk down below. The next one is a laccolith. Now what's happening here is it basically starts off the same as your lopolite. So what we've got here is we've got the magma pushing up, and what happens, it pushes the overlaying strata, it pushes upwards. All right, so remember, so this one is upwards, that one is downwards. Then we've got the dike, which is a wall-like intrusion, vertically, there we've got it, vertical wall-like intrusion. And then the last one is a sill, which is a horizontal rock formed as the magma has spread between the layers. Now, grade 11, if you have a look at these things, there are a few things that you must be able to do. The first thing that you must be able to do is that you must know these names. You must know the name word batholite. You must know lopolite, laccolith, sill, dike. You must know the names. The second thing is you must be able to identify this by means of its shape. Right? You must be able to identify. These are popular questions. You can get such a diagram in the exams. You see all these things. Ask, for instance, identify what is at 1, at 2, at 3, right? And the second thing, how was it formed? So you must know the name, you must know what it looked like, and the third thing is this, you must know how each of them has been formed. So these are the intrusive features with regard to igneous rocks. Now, what we are going to have a look at now, grade 11s, is this. Granite domes and tors. Granite domes and tors. Now, these two direct are formed because of massive igneous rocks. All right? You must understand this. It's quite easy. So let's have a look at this. Your granite dome, as you can see, look at the dome-shaped feature. All right? Granite domes are formed when batholites are pushed up to the surface. The covering rock layers are then eroded away. Can you see how important was the previous slide that I showed you? Right? The previous slide I've showed you that this is where the batholites are. It has been formed here. And what happens now is deep, very, very deep here in the Earth's surface. And what happens then, it has been pushed up through to the surface. All right? And that same thing that was lying, I don't know how many meters below the Earth's surface, it has been pushed up, and now it actually is shown on the Earth's surface as a dome. So that is your granite dome. Coming back to that again. Tors are formed when a jointed batholite is weathered along its joint, and a pile of coarse stones are left behind. It seems as if people have just stacked these rocks on top of each other. So that is very important. Now, what I'm going to do now is I'm going to have a look at granite domes, and I'm going to look at tors again. Right? Let's see what it's really all about. Now, granite domes can be tested on topographic maps. Tors cannot. All right? Remember, it's more a side view that is needed to see a tor. Right. So let's have a look at the granite domes. Now, As I've mentioned now in the previous slide, granite domes are formed when batholites are pushed up to the surface. The covering rock layers are then eroded away. Now, here we have a topographic map of Paarl. Now, if you think Paarl, you think Paarl Mountain. And this area here, this photograph here, represents this exact area on the topographic map, right? Here we've got, for instance, we've got Paarl Rock here. We've got Gordon's Rock here. We've got Britannia Rock here. These are all these rocks that you are seeing. All of them are domes. And it's an interesting thing, especially if you look at this thing. Did you know that Paarl Rock's initial name was Tortoise Mountain? Tortoise Mountain. That the Khoi called it Tortoise Mountain because of the shape of the domes on Paarl Rock. Now, okay, so now you've got these huge granite domes. Now, if you have a close look at granite domes, there's one interesting thing about granite domes. It can cut off your line of view, right? Very, very important that you must understand that. That the granite dome can be or serve as a blocking feature between yourself and something else that you would like to see. So, let us have a look at this. As I've said in the previous one, can you remember on the previous map that we had a look when we did horizontal layers? We told you there that you need to always integrate your map skills. We did bearing with you there. Now we're going to do a different map skill here at Igneous Rocks. That is very important. And this has to do with something called intervisibility. Now, let's have a look at this. As I've said, we've got Paarl Rock here, right? And sometimes it can cut off your line of vision. The question that we would like to ask, here we've got a school, right? Here we've got Paarl Rock. And the question is Paarl Rock visible from the school? All right? Is Paarl Rock visible from the school? Now, the children of Klein Niedeburg Secondary School there, they will tell you, yes, it is visible. Of course, we can see it. When you're at our school, the first thing we look up and we look towards the Paarl Mountain, towards the west, we see Paarl Rock. It is visible. The question is, do you know how to do it on a map? So let's have a look. Here we've got the school. Here we've got Paarl Rock, right? And the question is it visible from the school? Now let's have a look at this. Now when you do intervisibility, then it's very important that you must know heights. And that's very, very important, right? You cannot do intervisibility without knowing the heights of features between where you stand and the thing that you would like to see. You must know the heights. So let's have a look at this. The height of Paarl Rock, 543.1 meters. Right? There's a strict station there. And if you look at the school, here, there's a contour line just close to the school of 180. And I know many of you will say, right, 180 and the other 105, yes, I can't see it. No, you can't do that. Right? Because what you've got to do now is you've got to check in between. If there's something higher in between, then I cannot see it. So let's check all the contour lines in between. And then we see this. Now all that I've done was that I've put in the 100 meter interval contours here. Here we've got 200, 300, 400. In other words, what's happening now is that the landscape is actually rising in this direction from the school towards Paarl Rock. So, if I do this, and this is very important, remember grade 11s, you must be able, I mentioned it previously this afternoon, you must be able to draw cross sections. You know, in grade 12 we have so much problems with learners who still struggle with cross sections. Remember, you must be able to do this now in grade 11 already. And practice it all the time. You'll make life much easier for yourself next year in grade 12. Because cross sections, one of the most popular questions when it comes to your Mapwork section. Okay, so make sure that you know how to do a cross section. If not, please go back to your teacher. Ask him or her to explain it to you again. So let's have a look at what does this look like. Here we've got the school. Here we've got Paarl Rock. And now I've said, now let's have a look. 180 meters, 180 meters. Right? 543,1, 543,1. And if you draw a line, then you'll see there's no blocking feature between the school and Paarl Rock. In other words, you can come to the conclusion that Paarl Rock is indivisible from the school. But is that always the case? Is Paarl Rock indivisible from anywhere else, from everywhere else in Paarl? And then you'll see, but that's not the case. Let's have a look at this. Here we've got the Nantes Dam, right? The Nantes Dam, 600 meters, right? And Paarl Rock, 543. But see what we've got in between. In between, we've got a blocking feature because this height here is 654. There's something 54 meters high between the dam and Paarl Rock that's blocking your vision. So this is what it looks like. Here we've got the Nantes Dam, 600 meters. Here we've got Gordon's Rock. Have a look at that, 654. So Gordon's Rock is a blocking feature. This means that it's impossible for you to see Paarl Rock on the other side, and therefore we say that Paarl Rock is not indivisible from the dam. Paarl Rock is not indivisible from the dam. Okay, so grade 11, just to summarize all these things. We have looked at all the features now, whether it's your horizontal layers, your tilted layers, your massive igneous rocks. Please remember, you have not completed your work if you have done your content only. In geomorphology, you cannot proceed to anything else if you haven't done your map work as well. Right? And I would like to repeat what I said in the beginning, that when you are busy with geomorphology, you must think map work all the time. You mustn't think geomorphology, map work. We must integrate it with each other. Only then will you really understand this work, and you will be able to answer any question when it comes to your question paper or in the tasks that you have to do. So indivisibility is very important. See that you know how to do that. Now, yeah, I've just brought another photo, an interesting photo, just to show you. We've done the massive igneous rocks, the batholite. Here we've got the Nantes Dam, right? And here's this person standing, that is 600 meters, 654. In other words, that rock is about, say, 50 meters high. And right on the other side, exactly on the other side, there is Paarl Rock. So there's no ways that Paarl Rock is indivisible from Nantes Dam. That's a beautiful photo to show you what we really mean by indivisibility. Okay, the other one with regard to massive rocks is the formation of tors. Now, as I've showed you in my introductory slide, it seems as if somebody has just come and packed a lot of stones one on top of the other one. And no, that's not the way in which tors has been formed. Let's have a look at how these tors are formed. Right. Now, there's just easy three phases that you must remember. Firstly, you have your batholite here below, that's the Earth's surface. Let me first explain to you. In all three diagrams, this is the Earth's surface. Have a look at this. Here we've got widely spaced joints, all right? Very widely spaced joints that we have here. And what happens then is that chemical weathering takes place. Can you see what's happening now? Here? Between the joints. Here you see these stones are being formed already here, right? And have a look at this. And once all these stones have been formed, then this whole top material has been weathered, right? And has been eroded. And then this is exposed. Then it seems like a lot of coarse stones. That's a red, but it seems like one has packed one stone above the other. As you see, it's a completely natural process, and you get beautiful features like this, right? And now, if we come back to pile rock, you can also ask the question, but why didn't we find a Thor at pile rock? So let's just have a go. We go back at your pile rock and your Gordon's rock. What's very important is this. Widely spaced joints. There weren't any widely spaced joints there. Well, the result is the weathering couldn't take place. And you couldn't get that these coarse stones could be formed. And that is why we don't find Thors there. Okay, so that would be our Thors. Now, I would like to end of this section with a question. A typical exam question. Now, I put this at the end of everything. I didn't want to give you show you a question of each of them, because now we've got the integrated question that integrates all three of these landscapes: horizontal layers, your tilted layers, your massive layers. Now, the easiest way to study this is as follows. This will be the question, is a very strong possibility as a question in the exams. Let's have a look at the questions that they can ask you. They can ask you, for instance, identify the landforms A, B, and C. Right? That would be, of course, your mesa, your butte, and the conical hill. See, that one's the easiest one. Then they can ask you characteristics of it. An interesting characteristic, the way to ask characteristics, they can ask you, how does the conical hill differ from the butte? And the only difference is that the conical hill, the top hard layer, has been removed. All right? They can ask you, for instance, what is the similarity between a mesa and your butte? Of course, both of them have this hard layer. You see, interesting questions that they can ask you. They can say, okay, identify this at D. That would be, of course, your granite dome. You can see it's like that, right? Here's your tilted layers that we've got here, right? So here we've got a question that actually includes all of them, all these three landscapes that we have been talking about this afternoon. Now, how do you study them? The biggest mistake that you can do is to study, firstly, have a look at horizontal and go through all of them, and you end off with massive igneous rocks. That's the biggest mistake. Remember, in the exams, they want to know, remember our questions, what is it, where is it, why is it, all, what does it look like? And this is where you can really have a look at those questions with regard to a table. If you, for instance, have all our landforms here we've got a toe even there, all right? And you have the characteristics, and you've got how formed. In fact, I will suggest that you go make yourselves a table like that and study it this way, because this is the way in which it's going to be examined. You must be able to know the similarities, the differences, and the similarities between all of them. And you can only do that if on a piece of paper you've got everything like that. Don't study them separately. Okay? Rather do it this way. Right? And then, please don't forget, you must also integrate that with your Mapwork. Okay, don't forget that. I mustn't only study that, I must also know how does it work on the different type of maps. That's very, very interesting. So please, grade 11s, when you study this thing, right, really study to understand, right? Don't study to write, I know this and this and this and this, right? I must study with my questions in mind. What is it? Is a batholith. How has it been formed? Why is it there, right? What is the impact on the environment, right? These are the things that's very important when it comes to all these things. Okay, the next following topic that I'm going to have, would like to share with you would be slopes. And that is very interesting. If we have a look at this slope. Now, this slope, the photo here, I actually took this photo one day when I was on my way to Stellenbosch. This is in the Helshoogte Pass I took this photo. And because when I drove through there, I saw, but this represents all the slope elements, right? So let's have a look. Remember, a very important thing with regard to slope are your slope elements. Now, your slope elements are only 4 of them. That's the crest, the free face, the talus, and the pediment. And you must know all 4 of them. Now, if you look at your textbooks, and perhaps what you've done in class, mostly this would be done on a diagram, right? And as I've said, when I passed through this beautiful area, I actually just took this photo because immediately I saw it's going to be much easier to explain it to you on a photo than doing it on a diagram. So let's have a look at this again. The first thing that you must know is that we have 4 different elements of the slope, which I've mentioned already. Right at the top, you have the crest. The crest is a convex slope, right? And what happens there, is soil creep. Now, what is soil creep? It's just if you've got some soil here, and because we've got a steep slope here, because of gravity, it will just, go over the slope. So that's what we've got here, the crest. Then we've got the free face. Now have a look at the free face. You will see that it's very, very steep there, right? And deposition is totally impossible. If you've got, for instance, say a stone or something, or sand that have come loose, and they come through here, down here, it cannot be deposited there. It will go much further. It could deposit it here, the talus here. So that's the next one. Look at this. This is a very straight slope, very straight line actually, right? That is your talus slope. Now because it's straight and constant, deposition is the process that will occur there. And the last one is the pediment. Remember, the pediment is at the foot. You girls will know if you go for a pedicure, then have a look at your feet. Now, here we've got the pediment right at the bottom, and this is concave, the slope of the pediment. Deposition also occurs there. And between the pediment, the talus and the pediment, there we usually, somewhere around there, we usually get a nick point. Now, have a look at this photo, grade 11s, and compare it to the diagram that you perhaps have in your book. Compare it to it in your textbook, and try to identify these things, because this photo is reality. It's really where we have taken the facts of the content and we have applied it to reality, right? Now, what must you know of your different slope elements? Let's have a look. The first thing that you must know, the name of the elements. The crest, the free face, the talus, and the pediment. So you must know the name. The second thing that you must know is the shape of it, right? Convex, steep, straight and constant, and concave. right? That's what you must know, the shape. And the third thing that you must know is what are the processes that we find by each of them. Here we've got, again, soil creep, deposition, here also deposition, and there as well. Deposition impossible here, deposition here, and deposition here as well. Now if you have a look at this photo, grade 12s, and you go back to the questions that geographers ask that I've dealt with you in the beginning. Again, is it? What is it? Is the crest. Where is it? There you can see where it's right at the top. What does it look like? Right? Why does it look like that? What are the processes that can occur here? What is the impact on the environment? Look at the farming that we can find here. Why don't we have any farming there? Grade 11s, if I haven't convinced you by now, and there's so many times that I've showed you how to get back to the questions that geographers ask, then grade 11s, you will understand how very, very important it is to, when you study, when you prepare yourself, is to prepare yourself in the direction of the questions that geographers ask. And I don't know how many times I've mentioned this afternoon, to show you how it works in your different types of content that we've done so far. The contour maps, of course, on the slopes that we've had, shown you now. If you look on top, right, you will see, here we go, if you look at the crest here, right, it will be concave. Have a look at this. Concave. In other words, what does it look like? At the top, look, there's 400. There you get your contours close to each other. And the lower you go, the further the contours are. And here we've got the cross section. Look at that. Steep on top, and then it becomes more gradual at the bottom. So that is what is meant by a concave cave slope. And these slopes are very popular questions in your question paper. In your Mapwork question paper, grade 12s, slopes, please see that you know. But when it comes to slopes, remember, what is the basis of slopes? The basis of slopes is only something that I've mentioned before this afternoon also. It has to do with your contours, right? When your contours are close to each other, you're going to have a steep slope. And they're further apart, your slope is going to be gradual. The rest you can work out. Look at this. If you look at simply this concave slope that we had, here, if I know that when I get my when contours are close to each other, you're going to get a steep slope. Look at that. There's my steep slope on the cross section. There they further apart. There's my more gradual slope, right? And when it comes to the convex, it's just the opposite. And if you have a look at our previous slide again, our pediment is concave, right? What would the pediment slope look like on a topographic map? This is what it would look like, right? What would it look like? Convex slope, right? Here's 100 and there's 800, right? In other words, if you are here on a high altitude, then it's going to be a gradual slope. But at the lower altitudes, look at 100 to 500, look at the slope there. See how steep is the slope there? Grade 12s, I hope you realize how important your knowledge of contours, how important that is for your grade 11 and next year for your grade 12 examination. Very, very important. Remember that these, the basis of your contours, you have learned in grade 9 already. You've done these slopes in grade 9. You had a look at it. You've done them in grade 10 again. And now in grade 11, we are actually applying those skills to reality. That photo that I've showed you of the slopes, of the slope. When you see such a photo, you mustn't only see a photo, you must think contours. You must think, for instance, here the contours are going to be close together because I've got a steep slope. You must think that here I've got a concave slope. In other words, what does a concave slope look like? That is what a concave slope. A concave slope look like that. All right. So it's very, very important that you must be able to see these things, right? With regard to your map work. Very, very, very important. Okay. Our last topic has to do with mass movement and human responses. Mass movement and human responses. And here we've got a beautiful photo of mass movement. It seems like a landslide to me that has occurred here. Now, let's have a look at this. Now, again here, these are the things that you must know. Have a look again. What is the question? What is it? What is mass movement? Mass movement is the movement of soil, loose stones, and rocks down a slope. Remember, we've done slopes now in our previous topic. And if you are going to have a rock or something and just put it on the slope, it should roll down if it's steep enough. All right? When you've got this huge amount of debris moving down the slope, that is called mass movement. So let's have a look at the different types of mass movement. Soil creep, solifluction, landslides, rock falls, mud flows, and slumps. Now there's a reason why I prepared the slide like this. Again, I prepared it exactly the same way in which I showed you the previous one, when we looked at our landforms or landscapes, that you can see, must be able to compare it with each other. All right? Please don't study this as 1, 2, 3, 4, and so forth. Do it this way, and you'll see how easy it's going to make more sense for you. So let's have a look at this. Soil creep is the slow, downslope movement of soil. We've heard about soil creep now in our previous one. Solifluction. What is my keyword there? My keyword there would be rain. All right. So what happens is the debris becomes saturated with water and it goes down the slope. All right. Landslides. When a large amount of land breaks loose and plunges down the slope. Here we've got a landslide going down the slope. All right. Rock falls. That's when rocks break loose from the slope due to weathering, frost action, and earthquakes. And we've got these rocks, and this, very dangerous, just rolls down the slope. We've got our mud flows after heavy. Look at the key word there, mud flows. For mud, you need water. So there, as you can see, occurs on steep slope after very heavy rain. So that's very important. Here we've got a mudslide or mud flows. The rain and all this mud goes down the slope like that. And then the slumps, movement of material along nearly like in a spoon-shaped manner. Right. Now have a look at this. Again, I'm coming back to the questions geographers ask. All right? And again, please see how very, very important is this. And our first question was, what is it? All right? So then we've got mass movement. What is mass movement? All right? What does it look like? Here we've got the different types of, and we've got diagrams here. What does it look like? Look at this question. What is the impact on the environment? Right? Or what is the impact? Right? How can it be managed? Here are 1, 2, 3, 4, 5 questions of the questions that geographers ask. I cannot overemphasize this for you, grade 11s, to prepare yourself by means of this way in which I'm showing you now. So let's have a look of the impact of mass movement. Remember, to understand the impact, you must know what it is. You must know that mass movement is the movement of soil, loose stones, rocks down a slope. Here we've got. So here we've got it. Firstly, it accelerates erosion. Of course, erosion is going to take place. All right? It can destroy forests. As it moves down the slope, it takes the trees with it. This rocks, the movement of rocks, the movement of stones, the movement of soil can land in a river, can end up in a river. And then it can block the river. Then if you've got a home and it's in the way of something like this, there's no hope for you. Okay? It will damage you. It kills and injures people. It damages infrastructure. Have a look at this photo. All right? Here we've got a road here. If this happened and here were a few cars, those people haven't got a chance of survival. All right? How much do you think it's going to cost to repair this road, this infrastructure that we see? Look at the cars that have been lost because of possessions. And if you even had a house somewhere here, that would also be a problem. All right? So that is the impact of mass movement that you must understand. Then, how can mass movement be managed? See again, question that geographers ask. Firstly, to plant natural vegetation. Right? And if you plant natural vegetation, it will prevent the soil from moving. Engineering techniques, building retaining walls. Just hang on with this, I'm coming back to this again. Reduce deforestation. You'll see that actually joins up with plant natural vegetation. We want vegetation there because it will bind, the soil. It can't move then, right? The cut and fill of slopes. If you see as a steep slope, cut and fill and refill it. And then, if you've got unstable rocks on your slope, fasten them with bolts. Now, grade 11 is very important. That can you see again on one page, instead of having horizontal notes that you can study. See how easy you can make studying for yourself. And when you go to the booklet, the revision booklet, that actually should accompany this revision that I'm busy with you now, you will see that most of the topics are presented by means of mind maps. And in those mind maps, you will see the questions that geographers ask coming up all the time, and that we supply you with the answers that geographers ask as you move through the topic. So find out, as I showed you, easy ways that you can study, right? Instead of studying it, horizontal fact, all the time in a straight line like that. Do it this way, right? See if you can see changes. See if you can see patterns. Because that is what geography is all about. Okay, now, here's a case study. All right? And what I'm going to do is I'm going to, as I've promised you, today will be the day that we unpack case studies. How do you answer a question that deals with a case study? I've used this beautiful case study of Chapman's Peak. Here we've got a photo of Chapman's Peak. And here we've got the following written there. After two fatal incidents in 1999 and 2000, in which heavy rocks fell on cars, the following was done to make Chapman's Peak safer. Firstly, a tunnel and canopies were built on the steeper sections of the road. Rocks could overshoot the road. Have a look at this. Here we've got a concrete impact canopy. Here we've got another canopy now. So what happens now is that, can you see how steep the slope is? So if here should come a rock loose here, and here's a car, it will damage the car. But because it's so steep that the rock will come, it will bounce on the canopy and will fall into the sea below. So this is a case study, what has been done. All right. Then, secondly, catch fences were installed. Look at these catch fences here. So why are catch fences? So if you get a stone rolling down here, the catch fence will prevent it of reaching the road here at the bottom. Right? And then very important, stormwater drainage systems were installed in the slopes there. Now, you have learned that water, right, can really provide the energy that the slope will start to move, right? And so what I do is get the water, get it out of the slope as soon as possible, so a landslide, a rockfall can't occur there. Now, let's have a look at the questions. The question is, and I just want to run through the questions here. What was done to make Chapman's Peak safer? Identify the mass movement in the case study. Give a reason for your answer. During which season do you think it would be the most dangerous to drive along Chapman's Peak? Explain your answer. In a paragraph of approximately 8 lines, explain why mass movement can be regarded as dangerous. Now, those are the questions, exam questions, that accompany a case study in the exams. But now, how do you do a case study? All right? Now, this is a very important very important tips that I'm going to give you as to how to approach a case study. Let's have a look at this. How to do with case studies. Also, articles, you do exactly the same way. The first thing that you must notice, and that is, please, grade 11s, that first line is very important. It is not a comprehension test. Right? A case study, an article, it's not a comprehension test. Right? Let's see, what is it? It is used to set the scene on which questions are based. It's used to set the scene on which the questions are based. And I'm sure that when I unpack the case study with you and I showed you the questions, you should realize, okay, I know a little bit more because I know what the scene has been set there. Then the third thing that you must remember is that a small number of answers will be in the case study or the article. Especially your lower order questions will be there. Now, let's have a look at the questions again and see what happens here. The first one, what has been done to make Chapman's Peak safer? That's easy. There's 3 things that it's in the case study. It's easy, right? So you would be able to that's a lower order question. Let's have a look at the next question. Identify the mass movement in the case study. Give a reason for your answer. Now, nowhere in the case study it's mentioned what type of mass movement it is. In other words, this immediately isn't something that you can immediately, the name is not written there, right? But there's a lot of clues. It's talking about heavy rocks. So immediately you must know, okay, this has to do with rock falls. So that would be your middle order question. Now you'll see this one, the answers were in the question here. This one's, right, there was a slight possibility you had to use the case study to get the answer. Yes, this one. During which season do you think will be the most dangerous to drive along Chapman's Peak? Explain your answer. Now this is a higher order question, right? Because nowhere in the case study do you get the answer. But there is a hint for you. And the hint is here, stormwater drainage systems were installed. And being in Western Cape, you know that this receives winter rainfall. Am I right? So now you know that, okay, when it starts raining, certain parts of these slopes can become saturated. And what's going to happen now? Whoosh, goes down. All right? So if we have a look at our question again, you will see, during which season do you think it would be most dangerous? Definitely a higher order question. And you would have to explain your answer. That wasn't in the case study. Then you can also get a paragraph type question. In a paragraph of approximately 8 lines, explain why mass movement can be regarded as dangerous. You must explain why mass movement can be regarded as dangerous in a paragraph. And where you get your answer, you find your answer Here you get, right? Why is it dangerous? The impact on the environment. Okay? So that's very important, that you must know where to get the answers for these specific things. Grade 11s, can you see now what you must do with a case study? You know, when we mark your work, grade 11, and we get this in grade 12 as well, that we set a question and then you look for a line or a word in the case study or in the article or paragraph, and then you write down that line, you write down that sentence. And the whole answer deals with sentences or lines that have merely been written down from the case study, from the article. Please remember, you can't deal with this thing as if it is a comprehension test. Right? Of course you must understand what's happening. Right? But the method isn't the same. Because you are not going to find all the answers in there. Because the whole thing has been set, to set the scene on which the questions were based. So when you do your case studies in future, please bear all these things in mind, right? That you can really, remember, you can get full marks in a case study if you know how to deal with a case study. And if you know how to connect the case study to what part of the work. That's important, right? And see that you are in a position to do that. I would just like to conclude with a few exam tips, and these tips we usually give at the end of every revision that we've got, just to show you how important it is that what you must do during the exam. The first tip, plan. Right? Don't just jump into your work and start working. Plan your work. Secondly, organize your work. Thirdly, picture it. Picture it. Very important. What question that geography asks? What does it look like? Grade 11s, you must start to think in pictures. Must think in diagrams. Much easier to remember stuff. Much easier to recall stuff. Especially in geography. Remember that in one of the first few slides, I showed you the different types of data that can be used. Those are all pictures that can be used for you, on which questions can be based. So you must be in a position to think in pictures all the time. Going to be much easier for you that way. The second one, practice and revise. Remember, I've shown you here Mapwork stuff. I've shown you here how to deal with certain skills in Mapwork. Those skills, you will never ever be able to master those skills even if you watch this video 10 times over. It's not going to work. You have to sit and get it in all your textbooks are topographic map. You know the skills that you need for grade 11. Try and practice those skills on the topographic maps in your textbooks. And go to your teacher and ask, am I correct? And if you are not, please try to have your teacher, please let your teacher explain that and try to understand that you can apply that in any other map or any other diagram that you will see. And then refresh. The last one is refresh. When I was still at school, I would get a lot of my children, and they would say, sir, I studied for 5 hours yesterday. And I would ask them, and how many minutes of that 5 hours do you remember? I never asked them how many hours. How many minutes of that 5 hours do you remember? You can't study on end 5 hours. No ways that you can do it. Right? Remember when you concentrate. Right? What's happening is, if you start studying, then your concentration, goes lower, 5 hours. After 5 hours, there's nothing left. But what if you could study for, say, a 3/4 of an hour, right? Take a break, 10 minutes, 1/4 of an hour, out of every hour, break for 1/4 of an hour. Then what's going to happen? You're going to be refreshed. You want to high again. Go, and it goes down. Break away. right? 10, 15 minutes. There you've got your concentration back. You see, what's happening is you are refreshing your brain all the time. That is where we want you to be. Because that's the only way. Geography is a question paper that it plays mind games with you, right? Because everything has to do with pictures. Everything has to do with diagrams, right? It has to do with the application of stuff. And that is why your mind must be fresh when you are studying your geography. Grade 11s, I know that our session this afternoon, I truly hope that we have helped you a little bit with our with all the revision work that we've done. Thank you for having a look at this video. And what's very important, grade 11s, now the work lies with you, right? Nothing can be done by only having a look at this video. You will have to start working. You will have to use the things that I've tried to explain to you this afternoon. You mustn't listen to this video. You mustn't watch this video. It's not going to help anything. Use all these things. Use all the tips that we've shown you. Use all the ways in which we showed you how we've shown you how to integrate Mapwork in your different parts of the SCAP syllabus. Then I can assure you that geomorphology will then be fun with you, and you will be ready to answer any question for the exam. Thank you, take care, and goodbye.